Hello everyone, this is lecture 3, unit 3, matrix space. So in the last lecture we have seen that if f is continuous from a matrix space x comma to y, then it pulls back open set to open set if and only if that function is continuous. Now the same thing is here, that we have two matrix space x comma d and y comma star be a two matrix space, and that function, we have a function from x, a function from x to y, and f is continuous if and only if it pulls back closed set to closed set. That means we have a matrix space x comma d, we have another matrix space y comma d star, and we have a function f from this to this. Whenever f is closed in f inverse y, then the inverse image of that is also closed in x whenever f is continuous. The same thing whenever f is closed, if f inverse f is closed in x, then f is continuous. So we'll prove this. The necessary part, let f each continuous on x to y and f each closed in y. My claim is to show that the inverse image of f each closed in x. It is sufficient to show that f inverse f is closed in x. That means I will show that the complement of this is open in x. Now since f each closed in y implies the complement of f in y, that is y minus f each open in y. Since f is continuous, that f inverse of y minus f each open in x. This is because kindly since f is continuous, that means f pulls back open set to open set, open set to open set. So that f inverse y, that complement of f that is here, is open in y, the inverse image is also open in x. Now this is nothing but, this is y minus f, so this is nothing but f inverse of f complement is open in x. This is nothing but f inverse of y minus f, this total by outside of this f. This is nothing but y minus f means kana f ro complement, this outside of f, the inverse image ta kana haba itar outside haba 12 ta tar image pre image collection ta kana haba f inverse f ro complement in x is open in x. The complement is open in x implies f inverse f each closed in x. This is my part. Again now, so what is the thing that mote proof korba hoche f is continuous on x comma y dei che, f is closed in y dei che, nei chu ame will prove that f inverse f is closed in x. That is sufficient to show that the complement of this set is open in x. Since f is closed in y, the complement of f in y, that's why y minus f is open in y. Since f is continuous and f pulls back open set to open set, f inverse, that means f inverse of y minus f is open in x. This is nothing but f inverse f raw complement in x, because y minus f ta bahar ta point mane ta inverse image ta kada haba itar bahar ta haba is open in x. That implies the complement is open. This means f inverse f is closed in x. Now we'll see that what is the sufficient part. Given whenever f is closed in y, f inverse f is closed in x. My claim is to show that f is continuous on x. Let it is sufficient to show that f pulls back open set to open set. Let's I am taking let G be an open set in y. Now it is sufficient to show that f inverse G is open in x. Now G is open in y, that means the complement in y minus G is the complement of G in y is closed in y. By given condition, f inverse of y minus G is closed in x. So I am showing by the diagram. Suppose we have this x comma d and we have some y comma d star. G is open set in this, so f inverse G is G complement is closed in y. So this is f inverse G, that is need to prove that open. So f inverse G is in structure bahar dot mane this is nothing but f inverse of y minus G pre-image. What is that y minus G? Outside of that G tanko pre-image collection kana ba f inverse of y minus G, and that is nothing but that point mane e bhitre rahi na paron, because jodi bhitre rahla tar image ta na padba. But ame pre-image kaha nochu G ro bahar side ro image pre-image ta kana ba f inverse of y minus G. ताकि हमें कहाँ लिखवा दिस डॉटेड पॉइंट इज नथिंग बट y माइनस g. ओके ताकि हमें कहाँ लिखवा दिस इज नथिंग बट f इनवर्स g रो कॉम्प्लीमेंट मीन्स तार ई जेन डॉटेड लाइन रो प्री इमेजटा बाहरे ही पड़वा भितरे पड़ी ना पारे. सपोज भितरे जदि पड़ी गला तार इमेजटा इन भितरे पड़वा बाहरे तो नहीं पड़े ना. दैट्स व्हाई 12.1 को प्री इमेज कलेक्शनटा ई तार बाहरे पड़वा f इनवर्स g रो कॉम्प्लीमेंट इज क्लोज्ड in x implies what? F inverse G is open in x because complement is closed, then means f inverse G is open in x. So f pulls back open set to open set, that implies f is continuous. So this is the necessary and sufficient part for that f pulls back closed set to closed set. Now we'll see an example regarding this topic, means pulls back closed set to closed set, open set to open set. Example, let f is a function from x to y with d of xy is equal to 0 if x is equal to y, 1 if x is not equal to y, and this metric is called as discrete metric. But the proof ko whatever may be the metric space x and y with the discrete metric, f is always continuous irrespective of what is taken x and y. If it is with discrete metric, then f is always continuous. Okay, मते प्रूफ करवा छे कि f is continuous. Very simple. We take a subset of a subset of y which is open. Need to prove that f inverse a is open in x. Let a be subset of y, a is open in y. Need to show that f inverse a is open in x. Pulls back open set to open set है गले continuous है जीवा. Now f inverse a टा पक्का कार subset है बा x रो because inverse image. Now we know that every subset of a discrete metric space is open set. Open भी ऐसे, closed भी ऐसे. Now more open दरकार वाले I am taking the open set. We know that every subset of a discrete metric space is open set. hence f inverse A पक्का कणाबा is open in X is so A is open in Y tila f inverse A open in X ella implies f each f pulls back open set to open set into open set implies f each continuous. Okay, this is a simple example. Now next example, this criteria is also used for showing the non-continuity, not continuity or discontinuity. Fx is equal to 1 if x is positive, 0 if x is equal to 0, minus 1 if x is negative. This is called a signum function. Need to show that f is nowhere continuous, so that f is not continuous on R comma D. So it is sufficient to show that it cannot pulls back open set to open set. Let first I बुझू, we have R comma D here. 0 के केनो मैप करू छे, 0 सब का 0 के जाउ छे, ए सब एलिमेंट कहा के मैप होछन 1 के, एंड ई सब एलिमेंट कहा के मैप होछन -1 के रियल नंबर लाइन रे. तो रियल नंबर लाइन रे कण होछे 0 के ई मैप होछन 0 के जाउ छे खाली, एंड ई सब नंबर कहा के मैप होछन 1 के, एंड ई सब नंबर कहा के मैप होछन -1 के. ठीक, यारे जितने नंबर होछन 1 के मैप होछन और यारे जितने नंबर होछन कहा के मैप होछन -1 के, एंड 0 कहा के मैप होछे 0 के. ठीक, तो लेट g इज इक्वल टू -1 कमा 3. एमती गोटे नंबर नहीं गली जे -1 के 0 एंड 1 के रखी छे. ठीक अच्छे, was it f inverse g? तो we have taken a -1 comma 3 which contain 0 and 1 also. 0 रो प्रीमेज 0 है, 1 रो प्रीमेज टा कना पूरा ऑल पॉजिटिव रियल नंबर, बिकॉज जेबे जेबे एक्स्ट्रा पॉजिटिव है कार पाके जो छो 1 पाके, तो 1 रो प्रीमेज टा कना ऑल पॉजिटिव रियल नंबर है. तो f inverse टा कना क्लोज 0 to infinity, because 0 is for the 0 and infinity because all positive number कहा के मैं पे 1 के. तो g is open in where? वाह, हमें ई जगह तो y नो छो, x नो छो, y नो छो, but f inverse g is not open in x, so hence I can say that f is not continuous. That's clear. In the next video we will see some more example using this property. Thank you.